All right, this is where it becomes even more important to pay attention to the rectangle and the radius or radii. Right, so what we're going to do with this problem is we're going to take the same area as the previous two problems, A and B, and in C we're going to go around the line y equals 2 as the axis of revolution. So to do that, we're going to sketch in a rectangle into the area up against the line y equals 2, and we're going to be rotating around the line y equals 2. So if you imagine what's going to happen when you spin this rectangle, you're going to get a disk. Okay, and at risk of making everything worse there and less clear, you can probably imagine that, so I'm not going to draw any more in there. But anyway, it's going to create a solid disk. To do the volume using the disk method, we just need to figure out what R is. And R is going to be defined by the length of that rectangle. So what is the length of that rectangle? Well, if I took and wanted to go all the way up to the line, that would be the distance there would be 2. I'll denote that with a blue line. So that distance is 2. The whole thing here is 2. Okay? Then what we would need to do is take away the distance here from the bottom of the rectangle down to the x-axis. So we'll denote that with this red line here. Okay? So the distance that I want is going to be given by 2 minus off the red. What is the red? Well, that is just going to be the height wherever you draw the rectangle based on the function. So the height of the red line is square root of x. Okay? So our radius is going to be 2, the whole thing, minus square root of x. Okay? 2 minus root x. So our volume will be, the disk method again, pi, the integral from 0 to 4. The radius squared, so 2 minus square root of x, quantity squared, all with respect to x. So even though the axis of revolution has changed, we can adjust accordingly. So we just imagine, again, we go back to what is the radius of the disk. If this was a washer method, we would ask ourselves, what is the big radius? What is the small radius? And we would find the volume in that way. And we're in terms of x again because the rectangle is perpendicular to the axis of revolution. So we're going around a horizontal axis of revolution with the disk method.